So far, we have talked about rigid transformations, translations, reflections, and rotations. Those cause the shape to move around and change its position and its orientation, but it doesn't change the size of the side lengths, the angles, or the area of the shape. A dilation is a transformation where size and shape does change. The side lengths are bigger, the area can change, and it changes by a scale factor. A scale factor is a multiplier that causes the shape to get bigger or to get smaller, to enlarge or reduce. An enlargement is caused by a scale factor that's bigger than 1. Okay, that causes the shape to get bigger. If the new shape is 2 times bigger than it was before, 3 times bigger than it was before. A reduction is a scale factor between 0 and 1. So 0.5, 3/4, 1/3, okay? It causes the shape to get smaller. So they're non-rigid. Why? Well, rigid means that it's stiff, it stays put. A dilation doesn't stay the way that it was before. It changes in size, which means that a dilation is a non-rigid transformation. It's also called non-isometric. So let's take a look. We can dilate through the origin and we can dilate through any other shape. We're going to focus primarily on dilating through the origin. So let me show you what that looks like. It's easy when you take a shape like this. Our rule for a dilation looks like this. When it dilates through 0, 0, your original figure becomes the scale factor times x and the scale factor times y. So it's really simple. When you dilate through 0, 0, all you have to look at is the coordinates. So if you look at Q prime, which is my image, right, is at 4, 1, and Q is at 12, 3. Well, 4 times 3 is 12, 1 times 3 is 3. Now notice, it went from Q, this is my pre-image, right, my beginning image. This is my final image. You can tell because of the prime, P prime, R prime, Q prime, P, R, Q. And so you want to be careful to pay attention to what's your pre-image. We often forget because we think the image is the beginning, but it's not. Pre-image, before it got moved. P is at 3, 9, and P prime is at 1, 3. R is at 3, 3, and R prime is at 1, 1. What I notice with every single shape is that Q to Q prime is 12 divided by 3, 3 divided by 3. 9 divided by 3, and 3 divided by 3 gives me P prime. 3 and 3 divided by 3 gives me 1 and 1. That means this shape is 1/3 as big as this shape. Now, you can always tell, right? Maybe you don't remember. You go like, okay, well, this is 3 times bigger. So it's either 3 or 1/3. Remember, 3 makes it get bigger. 1/3 makes it get smaller. That's where you have to pay attention. It went from big to small. So my scale factor is 1/3. That is a reduction. It got smaller. And my rule is all of my original x's, my original was 12, it became 4. So my original x is now 1/3 of x and 1/3 of y. Whatever the coordinate is, I can multiply it by 1/3 and it will get me my image coordinate. Okay, as opposed to this one, my scale factor. So let's look at our image. So A is at 0, 2. B is at 2, -1, and C is at -2, -2. Now, B prime is at 4, -2. A prime is at 0, 4, and C prime is at -4, -4. So what you want to notice is that to go from 2, -1 to 4, -2, I multiplied all of these values by 2. I multiplied 0, 2 by 2 to get 0, 4. I multiplied -2, -2 by 2 to get -4, -4. Pre-image, image. It got bigger, which means I have a scale factor of 2. That is an enlargement. And my rule then would be my original numbers became 2 times bigger than what they were. Anytime you dilate through 0, 0, that's what it looks like. Now let me just kind of give you an idea of why it's called dilating through 0, 0, because this will help you understand how dilating not through 0, 0 works. Notice that if I connect the image and the pre-image, look at where they all trace back to. They all go back to the origin. That's what dilating through 0, 0 means. So here's what you want to think about this like. This is my projector. And notice the closer you are to the projector, if you stand in front of a projector, then if you step between it and a movie screen, say you're projecting to the wall and you step in the middle, the image is going to be smaller on you because you're standing closer. And the farther away, the bigger it gets, just like a flashlight, right? It's brighter right here than it is back here. So that's following these lines of perspective. This is used in perspective art. The same thing happens here. You can't see it as well because of the dark triangle, but if you were to connect B to B prime, A to A prime, and C to C prime, you'll see that they all pass through the origin right here. So kind of think of it like this too. It's where you put your finger on your phone, right? When you do this, everything gets bigger. If you do it to the side, it's going to go like that and get bigger that way. So let's look at another problem. In a dilation, so in a size change, CP prime, so this is my final image, is 4, and CP, so the length, CP stands for a segment. So we started with, this is C prime, P prime, and it's 4, and I started with CP, and it's 20. Well, to go from, this is my pre-image, right? This is my pre-image, I can tell because of the notation. This is my new image, my image, right? So it went from 20 to 4. That means it is a reduction, and the scale factor, how did we go? We divided by 5. So we multiplied by 1/5. Scale factors are always done as a multiplier. So we want to know, what did we multiply by? So dividing by 5 is the same as multiplying by 1/5. So the good thing about this, and I want to graph them just so you can see it, but just so you can see how it changes by the scale factors. So E is at -2, -2, F's at -2, 4, G's at 2, 4, and H is at 2, -2. So here's my original shape, and I want to multiply it by a scale factor of 0.5. So think about it. Does that mean that it's going to shrink or get bigger? Okay, it's going to shrink. 0.5 is smaller than 1, so it's going to get smaller. So we take EE and we multiply it. We take E, -2, -2, and we multiply it by 0.5. That's -1, -1. There's E prime. F will be at -1, 2. There's F prime. G will be multiplied by 0.5 and be at 1, 2. That's G. And H is at 1, -1. And so what we can see is that it got half as big, right? So all of my side lengths, now the area is a different scale factor, but my side lengths are half of what they were before, okay? So you would have taken X, Y, and multiplied everything by 0.5X and 0.5Y to get your new position. Okay, this one, if I want to use a scale factor of 2, then I would take x, y, and I would multiply it by a scale factor of 2, so it would be 2x and 2y. If A is at -2, -2, B is at -1, 2, and C is at 2, 1, if you multiply all of those by 2, then you end up with -4, -4, that's A prime, -2, 4, and 2 becomes 4, 2, 2, 1 becomes 4, 2, and so here's my new shape and my new images, my new image. Okay? 1/3, so we could do this. If all I want to know is where are the new points going to be, if I am going to shrink, right? My scale factor is 1/3, so it's going to get smaller. It's a reduction. Then 0 times 1/3, so we want to take x, y, and we're going to multiply everything, every x and every y, by 1/3. So think about a photo or a picture that you put in a Google slide. If you grab it by this corner right here and you drag it, then the entire shape is going to get bigger, right? Now, if you take that same shape and you grab it right here and drag it, then all that's going to change is it's going to get wider. So now the people in your photo have gotten wider. If you take it, same shape, and you grab it here and you drag it up, then everybody in your picture is going to get taller and thinner, okay? So what happens is, if you do one of these, right, you're just multiplying either the x or the y, but not both. If you want to grow the whole thing or shrink the whole thing, you have to grab it by the corner, which means you're changing the x and you're changing the y. Essentially, you're doing it this way and that way, which results in that, okay? So we're going to take everything and multiply it by 1/3. 0 times 1/3 and 1/3, right? My image of B would be 3 times 1/3 is 1 and 1. C prime 6 times 1/3 is 2, and 3 times 1/3 is 1. And D prime 3 times 1/3 is 1, and negative 3 times 1/3 is negative 1. And so there would be all of my image locations. And then this one I just want to talk about kind of quickly because I think you get the point. Your scale factor doesn't have to be a whole number, which, I mean, this isn't a whole number, but we can kind of accept this one, but we have a hard time. Well, this just means it's 2.5 times bigger, or we're multiplying everything by 5/2. And so all you would do is you would take x, y, and you would make it 2.5 times bigger. So you would make your x 2.5 times bigger, and you would make your y 2.5 times bigger. So you would multiply x by 2.5, multiply y by 2.5, and you can get decimal answers. That's okay. You would just, when you graph it, you would go, like, if it was 2.5, you'd go over 2 and then up. Now, you have to be careful here. Notice this one's tricky because it counts by 2s. Okay, so be careful if you need a half or you need an odd number because you would have to go in the middle. Okay, now what does it look like if it is not dilated through 0, 0? So this is just extra bonus material. You're not going to be tested over this material in our classes, but if you want to know and kind of see what's going on, let's take a look. So triangle ABC, we have our pre-image is at -2, 2. B is at 1, -1, and C is at 0, 2. So we're back here. We have our original triangle. It says find the image of A prime, B prime, C prime after a dilation centered at -5, -4. So here's what's happening. -5, -4. -5, -4. So this time what I want to do is basically imagine this. I'm going to put, instead of putting my fingers in the middle at 0, 0 and dragging it out like this, or here and dragging it out like that, I'm going to put it over here to the side, right? And basically what's going to happen is you're going to kind of have this kind of projection, but now my flashlight has shifted positions. It's no longer sitting here at 0, 0. That's the only difference. And this isn't really too bad. So what we want to use is slopes. We're going to use those and make it a lot easier. So remember I said earlier that we can tell where the center of dilation is by connecting the image to the pre-image, which will always connect back to the center of dilation, which up until now has been 0, 0. Well, if you connect the center of dilation and the point and just draw a line, I'm going to do the same thing with C and the same thing with B. Okay, so here's what you want to do when you're dilating through a point other than 0, 0. Now, there's a rule for this, but it's really big, bad, and ugly. In fact, if you look right here, it looks like this. You don't want to learn that, right? You don't want to have to deal with that. This is so much easier just understanding how your graph works. So look right here. So to get from the dilation point to A, I went up 1, 2 over 1, 2, 3. Well, if I want to dilate by a scale factor of 2, what that means is I want to do that twice. So I went up 2 over 3. That's one time. I'm going to go up 2 over 1, 2, 3, and I'm going to put a dot. Notice that it's on that line. That's my new A prime. It's that simple. That's all you have to do. Okay, now let's do B. To get from the center of dilation to B, we go up 1, 2, 3 over 1, 2, 3, 4, 5, 6. I want to do it a second time because I had a scale factor of 2. 1, 2, 3, 4. Oh, no, it was 1, 2, 3. So from B, sorry, 1, 2, 3, 1, 2, 3, 4, 5, 6, and it's on my line, so that means I'm good. There's my B prime, and then I have my C to get from my origin to C. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Do it again. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And if I wanted to make it 3 times bigger, I would do 3 stair steps. If I wanted to do half, then I would do half a stair step. So you can use this concept, and you can even use this up here with dilating through 0, 0. It's just dilating through 0, 0 has an easier rule. Okay, and so now we can see that our new A is at 1, 0. Our new B prime is at 7, 2. And our new C prime is at 5, 8. And that's what it looks like to dilate through -5, -4. Essentially what we've done is we've just shifted our new origin. We just pulled our flashlight back so that it had a new starting point. And if you connected those, then you would have your new shape. Notice it's on your lines. Those are those lines that when you learn to draw in perspective, sometimes you have to draw those in. That's what these are, is you start at that perspective. It's that point of perspective. So you can see the triangle looks the same. You can see the triangle looks the same. It's just bigger. And it's just, think about it. It's just backing away from the flashlight, and so the light's getting bigger, or backing away from the projector. And so it makes the picture bigger on whatever screen you're casting it on. So a dilation is a non-rigid transformation. It changes size because the side lengths and the area is affected by a scale factor.